Okay, in stoichiometry 1, you learn that there is a molar relationship involved with the balanced chemical equation, meaning that the coefficients in the balanced chemical equation will tell you, it's essentially your recipe, how many moles of each substance you would need in order to react and get the right amount. Okay, so that's fine, but we have to remember that the balanced chemical equation relates to moles only. So if you are given a quantity in, say, something like grams instead of moles, then you're going to have to convert from grams to moles. Or vice versa. If you're given moles and then the question is asking for grams, you're going to have to go from moles to grams. So we're going to combine what we did last week, which was to learn our mole conversions between mass and moles, and our stoichiometric ratios that we learned from stoichiometry 1. So let's get ourselves a balanced chemical equation here. All right, I give you some substances here. We have calcium, we have hydrochloric acid, and that's going to form calcium chloride and hydrogen. Okay, so I'm going to go ahead and write this out. We've got calcium, and we have HCl, and that's going to form calcium chloride. Calcium's a plus 2 and chloride's a minus 1, so you need 2 chlorides for every calcium. And then we have hydrogen gas, H2, because hydrogen is part of the HNO7. So now, in order to balance this so that we have the same number of atoms on each side of the equation, following the law of conservation of matter, we've got 2 hydrogens over here, 2 chlorines here, so it makes sense to put a 2 right here. So that means that our ratio, our recipe essentially, is we're going to need 1 mole of calcium for every 2 moles of hydrochloric acid to form 1 mole of calcium chloride and 1 mole of hydrogen. Okay, so now let's look at this problem. I think it's A on your sheet. Okay, it says, how many moles of hydrochloric acid are needed to fully react with 10 grams of calcium? So our dependent, what we're trying to get to, are moles of hydrochloric acid. Our independent, which is given to us, is 10 grams of calcium. Okay, we said that this relationship, the 1 to 2 to 1 to 1, is in moles. And so we need to get our 10 grams of calcium into moles. So we've got 10 grams of calcium. How do we go from grams to moles? We divide by the molar mass. So we're going to divide by the molar mass of calcium. See how grams cancel. Now we're going to be in moles. And when you do that math, you end up with 0.25 moles of calcium. Oh, I'm sorry, hydrochloric acid. Or no, that's calcium, sorry. And so we have 0.25 moles of calcium. And so we're going to put that right here. Okay, so that's how many moles of calcium we have going in from the 10 grams. Now, how is that going to relate to our hydrochloric acid? Well, it's a 1 to 2. So that means we're going to have twice as many moles of hydrochloric acid. 2 times 0.25 is 0.50. And so that's how many moles of hydrochloric acid you would have. You would need to fully react. Now the question goes on to ask how many moles of calcium chloride and hydrogen are formed. Well, if we have 0.25 moles of calcium, then we have 0.25 moles of calcium chloride because it's a 1 to 1. And if we have 0.25 moles of calcium, then we have 0.25 moles of hydrogen because, again, it's a 1 to 1 relationship. Okay, so our first step was just to convert to moles, and then we can see the relationship from the balanced chemical equation from that. Okay, let's go on and do the next example. Okay, so I still have my 1 to 2 to 1 to 1 up here. Okay, but this time it's asking how many grams of hydrochloric acid are needed to fully react with 2.3 moles of calcium. Okay, so we know we have 2.3 moles. So this time you're given moles. Okay, so now we're trying to get to hydrochloric acid. So what is our relationship from calcium to hydrochloric acid, it is a 1 to 2. So that means we have 4.6 moles of hydrochloric acid. And now their last thing it's asking for is grams of hydrochloric acid. And so we're going to have to convert our moles of hydrochloric acid to grams of hydrochloric acid. And how do we get a 4.6 moles of HCl? How do we go from moles to grams? This time we're going to multiply by the molar mass of HCl, which is 36.46 grams. So when you do that, you end up getting 167.67 grams of HCl. Okay? And so again, we converted from moles to moles up in the table. Then we went to grams by multiplying by the molar mass. Okay, the rest of the question is how many grams of calcium chloride and hydrogen are formed. Well, again, we know we have a 2.3 calcium, so how much calcium chloride would we have? And hydrogen, 2.3 and 2.3. Why? Because it's a 1-to-1 relationship. So now that we have our number of moles, can we go from moles to grams? Yeah, same process as what we did with the hydrochloric acid. If we have 2.3 moles, then we're just going to multiply by the molar mass of first calcium chloride, which is 110.98. And then we do the same for the hydrogen. The only way it changes is we're going to multiply by a different molar mass, 2.02 for hydrogen versus 110.98 for calcium chloride. Okay, and so when you do this, 2.3 times 110.98 is 255.25 grams of calcium chloride and 4.65 grams of hydrogen. Notice you get a lot less mass of hydrogen than you do calcium chloride. Why? Well, because it weighs a lot less. Hydrogen is a very, very small atom. So here are 3 masses that we get out from this one input of 2.3 moles of calcium. Okay, I'm going to squeeze in one more here. All right, let's do 9.5 grams of calcium, and we want to figure out grams of hydrochloric acid. So again, we're starting with grams of calcium, and in order to do our relationship, we have to get to moles. So we're going to start by going from grams of calcium to moles of calcium, and we do that by dividing by the molar mass this time. And when you do that, you get 0.24 moles of calcium. So we get 0.24 moles of calcium. Now we're trying to get to grams of hydrochloric acid. Well, we can't go from the only relationship we have are in moles. So what's our molar relationship between calcium and hydrochloric acid? It's a 1 to 2. So if we have 0.24 moles of calcium, then that means we have 0.48 moles of hydrochloric acid. So if we have 0.48 moles of hydrochloric acid, but they want us to get to grams of hydrochloric acid, we need to then multiply by the molar mass to get to grams of hydrochloric acid. So notice over here, we divided by the molar masses to get to moles. Over here, we're going to multiply by the molar masses to get to grams, okay? So when you do that, you end up getting 17.3 grams of hydrochloric acid. Okay. Now, so notice that I broke this up into kind of 2 different steps, getting moles in the middle, and then putting moles up into the table to figure out the moles, and then I came back down and I figured out the grams. So I broke it up into 3 steps. In the next video, I'll show you how to do it all in one step.